Hello students, I'm Pushkar. I'm discussing KVPY 2020 SX Paper 1 Chemistry. Here is a question, a very simple question. Velocity of the revolving electron of helium plus in the first orbit is V. The velocity of the electron in the second orbit will be what? V 0.5V, 2V and 0.25V. For this either we need to derive or we need to remember this expression for velocity Vn, which is given by Z into K. K is the Coulomb's constant, uh, the constant involved in the Coulomb's law. Z is the, of course, nuclear charge, which is here 2 positive, into 2 pi e square upon nh. So that is the expression for velocity in the nth orbit. So in n is equals to 1, obviously we have this, and when you just change n is equals to 2 in the second orbit, there is a n factor in the denominator. Rest everything will be the same. So of course v1 upon v2 should be equal to 2 upon 1, and since it is uh, v1 upon v2 is equals to 2 upon 1, because v1 is equals to proportional to 1 and v2 is equals to proportional to this. So the answer is, of course, v2 is equals to v1 upon 2. So the answer is, of course, B option. So should we derive this for getting this? It's not difficult at all, if even if we want to derive it, because we know that mvr is equals to, from the Bohr's law, nh upon 2 pi. And so v is equals to, from this we can get n into h upon 2 pi into m into r, where r is the Rn, that means radius of the nth orbit. Okay, and radius of the nth orbit, if you calculate, comes out to be n square h square upon z into k 4 pi square m e square. So if you substitute this equation number 2 in equation number 1, you will get expression for Vn, and the expression for Vn then looks like nh divided by 2 pi m, and instead of Rn now we are going to write n square h square into z into k into 4 pi square m e square. If you solve it, this is going to be cancelled. This is 2 pi is going to be cancelled with, is going to be 2 pi, and this m is also going to be cancelled with this m. So obviously we have this expression, Vn is equals to zk 2 pi e square upon nh. And that means Vn1 upon Vn2 is equals to n2 upon n1. That's the basic funda of this problem. So for most of the students, for the Bohr's model, they remember this. So for those students who remember this expression, at least if they remember this expression, how Vn is related to the principal quantum number n in the Bohr's model, this question is quite easy and straightforward. Let's see what is there in the predicted solution. So V is equals to V naught into Z by N. And so of course, that's the answer. So stay tuned for many such solutions. Thanks for watching.